Today's topic is magnetosonic wave. Magnetosonic wave is low frequency MHD wave produced in plasma by oscillations of ions in the presence of magnetic field when the propagation is perpendicular to the direction of magnetic field. So, magnetosonic wave is produced in plasma by oscillations of ions in the presence of magnetic field and when the propagation is perpendicular to the magnetic field. When propagation is along the direction of magnetic field, it will be alpha wave, and when propagation is perpendicular to the direction of magnetic field, it will be magnetosonic wave. Frequency of this wave is much smaller than the ion and electron cyclotron frequency. Consider a wave propagating along the y-axis, electric field is along the x-axis, and magnetic field is along the z-axis. A mechanical force acts along y-axis, hence the plasma is compressed and rarefied along the y-axis. The equation of motion for ions is this. This is the equation of motion for ions. M, capital M, which is the mass of ion, N0 delta V1 upon delta T equal to N0 E into E vector plus V1 vector cross B vector minus del Pi. Here N0 is the density of ions. It is the number of ions per unit volume. So M is mass of each ion. So Mn0 is mass per unit volume, mass of ions per unit volume. It is the density of ions. N0 is number of ions per unit volume, number density. If we multiply by capital M, mass of each ion, then capital M into N0 represent the mass of ions per unit volume, and multiplied by dV1 upon dt, it represent force per unit volume. Mass into acceleration is force, but mass is for unit volume. Mass is Mn0 is mass per unit volume. So left hand side will represent the force on ions per unit volume. In right hand side, the first term is N0 E into E vector plus V1 vector cross B vector. This represent the force on ions per unit volume due to electric and magnetic field. E is charge on each ion. So on each ion the force will be small e into E vector plus V1 vector cross B vector. And if we multiply by N0, that is number of ions per unit volume, then this will be the force per unit volume due to electric and magnetic field. And the last term is minus del Pi. Here Pi is ion pressure and it is given by gamma I N1 K Ti. It is ion pressure. So minus del Pi will represent the force per unit volume due to ion pressure. In this term Pi, which is ion pressure, it is equal to gamma I N1 K Ti. Gamma I is constant for ion, K is Boltzmann constant, Ti is ion temperature, and N1 is number of ions. It is the change in number of ions per unit volume. N0 is number of ions per unit volume, and N1 is a small change produced in it. So this is the equation of motion for ion. We write it as equation 1. Now put the value of Pi. Then we have mn0 delta V1 upon delta T equal to n0 E into capital E plus V1 vector cross B minus gamma I K Ti del N1. This del, which is before Pi, now this del is for N1. Minus del Pi is equal to minus gamma I K Ti del N1. There is variation with distance for N1. Now we write the x and y components for this v1 vector, or we can write it as vi vector, which is velocity of ion. It is actually change in its velocity. And then in terms of x and y components, this equation 2 becomes, x component of it is mn0 delta Vix upon delta T. Vi is velocity of ion and Vix is its x component, equal to n0 E Ex plus Viyb. X component of E vector is Ex and x component of V cross B can be determined by making a determinant. In the determinant, we write first row as ijk. In second row, we put the components of V vector, that are Vix, Viy and Viz. And in the third row, we put the component of B vector, that are 0, 0, B, because B vector is along the z-axis. So by solving that determinant, we can solve this V vector cross B vector and find its x and y components. So its x component comes Viyb. Vy is Viy, it is velocity of ion, and Viy is the y component of ion velocity. Similarly, this equation 2 we can write its y component as mn0 delta viy upon delta t equal to n0 e into minus viyb. Now here y component of E vector is 0 because E vector is assumed along x-axis, and minus VIYB is the y component of V cross B. And similarly in last term we have minus gamma I KTI, and del n1 will have y component as delta upon delta y n1. Delta n1 upon delta y, it is for del n1 its y component. Its x component is 0 because wave is propagating along y-axis. Because the wave is propagating along the direction of y-axis, so there is change in n1 along the direction of y-axis, and along x-axis there is no variation in it. So in x component equation we did not write this term, and for y component equation we write this term and write the component of del vector as delta upon delta y. Now we get these two equations. Equation 3 and 4 for x and y components of equation of motion for ion. Now assuming plane wave solution as e to the power minus I omega t minus ky. Since wave is propagating along y-axis, so we write ky. If we assume such plane wave solution, then we can find differentiation with respect to t, delta upon delta t as minus I omega, and differentiation with respect to y as delta upon delta y will be equal to ik. Since with t we have minus I omega, so delta upon delta t is equal to minus omega I omega, and since with y we have ik, so delta upon delta y is equal to ik. So we have delta upon delta t equal to minus I omega and delta upon delta y equal to ik. Put these values of delta upon delta t and delta upon delta y in above two equations, which are for x and y components, equations 3 and 4, then we get these two equations, equations 5 and 6. For x component we have mn0 delta upon delta t we write as minus I omega Vix equal to n0 e ex plus Vib and this from this first equation we write value of Vix, x component of ion velocity, dividing by minus I omega mn0. We get Vix. It is IE upon m omega into Ex plus Viyb. This is Vix. Write it as equation 5. And from y component we have mn0 minus I omega Viy equal to n0e minus Vixb minus gamma I kti ik n1. Ik here is written for delta upon delta y, and minus I omega is written for delta upon delta t in this equation of motion for y component. Value of Vix in terms of EI, y is given by this first equation, which is equation 5, and now we write for VIY. VIY is obtained by eliminating other terms in left hand side of this equation, or by dividing by minus I omega m and 0. By dividing by minus I omega m and 0, we get VIY equal to IE upon m omega minus VIX b plus k gamma I k ti n1 upon n m omega n0. Put this equation as equation 6. Now from equation of continuity, this is the equation of continuity, del dot j plus delta rho upon delta t equal to 0. The equation of continuity is the equation which relates current density J and charge density rho. Since current density J is NeV and charge density rho is Ne, E is cancelled out and we get equation of continuity as del vector dot Nv plus delta N upon delta T equal to 0. It is from del vector dot j vector plus delta rho upon delta t equal to 0. And for current density j vector we have NeV vector, and for charge density rho we have Ne. So now equation of continuity now becomes this. From this equation of continuity we write del dot Nv. So in place of del vector we write its y component, that is delta upon delta y, and take y component of v vector also, because if we take delta upon delta y for del vector we write v, in place of v vector we write VIY, y component of ion velocity, and for n we write n0. Then first term becomes n0, n is actually n0 plus n1, and from this term we get only n0 neglecting n1. So n0 delta upon delta y VIY plus delta n upon delta t. In place of delta n upon delta t we write delta n1 upon delta t. We are using small perturbations in n and v, so that n becomes n0 plus n1 and v becomes, we can write n as n0 plus n1 and we can write v as v0 plus v1. n0 and v0 are the equilibrium values and n1 and v1 are small perturbations. So if we write for n as n0 plus n1 and for v we write v0 plus v1, then in first term we have multiplication of two such terms, n into v. So from n we take n0 and from v we take v1, and for that v1, that is change in perturbation in v1, we write as VIY, its y component as VIY. So it is y component. For ion velocity VIY, it is for V1, perturbation in velocity. And for del, we write delta upon delta y. And in the second term, we take N1, assuming that the changes in N0 and V0 are negligible. So we take the equation. In the second term, we write N1 for N. In the first term, we write N0 for N, because in the first term we have another quantity V, which is V0 plus V1, and in the second quantity V, for this second quantity V, we write V1, and V1 is written as VIY. Now put delta upon delta y as Ik and delta upon delta t as minus I omega. This equation reduces to this: N0 Ik VIY plus minus I omega N1 equal to 0. From this equation, we write N1 upon N0 as K VIY upon omega. Substituting this value in equation 6, this is equation 6 for VIY. Here in equation 6 for VIY, in second term we have N1 upon N0. In equation 6, in second term, we have N1 upon N0, and this value of N1 upon N0 we put from here. The value of N1 upon N0 is K VIY upon omega. If we put the value of N1 upon N0, this equation 6 become VIY equal to IE upon m omega into minus VIXB plus K square gamma I K TI upon m omega square VIY. Note that we are using two K. One is small k and other is capital K. Capital K is used only with this temperature Ti. K Ti is thermal energy of ions. K is Boltzmann constant, capital K, with temperature Ti. And this small k is propagation vector, which we write in plane wave solution as e to the power minus I omega t minus kx or ky. So now for VIY we have this expression. There is another term of VIY in right hand side. Bring it to left hand side and take VIY common. Then we have VIY into 1 minus k square gamma I k ti upon m omega square equal to minus IE VIX b upon m omega. And from this we get the value of VIY as VIY equal to minus IE VIX b upon m omega into 1 minus k square gamma I k ti upon m omega square. Now EB upon m, EB in numerator and capital M in denominator. This EB upon m we can write as omega I. It is ion cyclotron frequency. Ion cyclotron frequency is EB upon capital M. We write it as omega I. Then VIY becomes minus I VIX omega I upon omega into 1 minus k square gamma I k Ti upon m omega square. Write this as equation 7. Now from equation 5, Vix equal to, equation 5 is this. For Vix, it is IE upon m omega into Ex plus VIYB. So here we put the value of VIY to find the value of Vix. In this relation 5, we put the value of VIY and get the value of Vix as. Vix now will be equal to IE upon m omega into Ex minus, here we put the value of VIY from this previous equation, VIY. So it is Vix equal to IE upon m omega Ex minus I Vix omega I B upon omega into 1 minus k square gamma I k Ti upon m omega square. Now Vix is in left hand side and Vix is also in right hand side in second term. Multiplying this, simplifying this right hand side, IE upon m omega is multiplied in both the terms, we get these two terms, and from these two terms in this second term again EB upon capital M appears, and again we write this EB upon capital M as omega I. Omega I is already there, so this will now becomes as omega I square. By putting EB upon capital M as omega I, we now have this second term of right hand side as Vix omega I square upon omega square into 1 minus k square gamma I k Ti upon m omega square. Now take this second term of right hand side to left hand side, because the left hand side term contains Vix and this second term on right hand side contains Vix. So we bring these two terms together to left hand side, take Vix common, then it becomes Vix into 1 minus omega I square upon omega square into 1 minus k square gamma I k Ti upon m omega square equal to IEX upon m omega, or Vix will be equal to IEX upon m omega into this whole term inside the bracket, 1 minus omega I square upon omega square into 1 minus k square gamma I k Ti upon m omega square. Now from Maxwell's equations we have del cross, Maxwell equation is del cross E equal to minus delta B upon delta T. So for small perturbations we write these as del cross E1 equal to minus delta B1 upon delta T. E1 and B1 are small perturbations in E vector and B vector, and other Maxwell's equation is C square del cross B1 vector equal to 4 pi J1 vector plus delta E1 upon delta T. J1 is also a small perturbation in the value of J. From these Maxwell equations we have C square del square E1 equal to 4 pi delta J1 upon delta T plus d2 E1 upon dt square. This we can obtain by by differentiating second equation, so that we get, in place of b1 vector we get delta b1 upon delta t, and in right hand side we have, in place of j1 as delta j1 upon delta t, and in the second term we have d2 e1 upon dt square. So we differentiate with respect to this second Maxwell equation, that is fourth Maxwell's equation actually, and then in left hand side, in place of delta b1 upon delta t, we write as minus del cross e1 from this previous equation, which is Maxwell's third equation. Then we get this relation, c square del square e1 equal to 4 pi delta j1 upon delta t plus d2 e1 upon dt square equal to 0. Assuming plane wave solution as e to the power minus I omega t minus kx, we have delta upon delta t equal to minus I omega and delta upon delta x equal to ik. So we have c square minus c square k square ex. Now it is del square. For del we write delta upon delta x, that is ik. So for del we write delta upon delta x, that is ik. So for del square we write ik into ik, that is I square k square, that is minus k square. So for del square we write minus k square, and we have minus c square k square ex equal to minus 4 pi. For delta upon delta t we write minus I omega, j1x, and for d2 by dt square we have minus omega square, because delta upon delta t is minus I omega. So 2 times differentiation with t will give d2 by dt square, that is minus I omega into minus I omega, that is minus I square omega square, that is minus omega square. So we have minus omega square e, and we write its x component. So for e1 vector we write ex, for j1 vector we write j1x, for e1 vector again we write ex. It is for x component of this equation. Taking ex common, we have ex into omega square minus c square k square equal to minus 4 pi I omega j1x, and for j1x we have NIEVIX plus NEEVEX. Current density is NEV. For ions it is NIEVIX, x component, and for electrons it is minus NEV, and for electrons we write NEEVEX. Ni and Ne are ions and electron concentrations. These are number of ions per unit volume and number of electrons per unit volume. Vix is x component of ion velocity and Vex is x component of electron velocity. So J1x is written as, from the formula J equal to NeV. We write for ions as NiEVix, and for electrons we write minus NeEVEX. Charge on electron is minus E, so it is negative. Ni and Ne, number of ions per unit volume and number of electrons per unit volume. We assume this as N0. So write Ni equal to N0 and Ne equal to N0, and this N0 is taken common. Then this becomes minus 4 pi I omega n0 e Vix minus Vex. For electrons, expression for Vex can be obtained in a similar manner as we find Vix. Equation 8. We find Vix by this equation 8. This is x component of ion velocity. In a similar manner, we can find x component of electron velocity, that is Vex, and write this Vex equal to minus IEEx. This is obtained by replacing E by minus E, capital M by small m, and I by E. I is for ion, for which we write E, that is for electron. Mass of electron is now small m, so in place of capital M we write small m, and charge on electron is minus E, so we write minus E in place of E, and obtain this expression for Vex, x component of electron velocity, minus I E Ex upon m omega, now it is small m, into 1 minus omega E square. In previous case it is omega I square, now we write it as omega E square. Omega E is now electron cyclotron frequency. Omega E square upon omega square into 1 minus k square gamma E k Te upon m omega square. So in place of gamma I we write gamma E, in place of Ti we write Te. That is for electrons. Electron cyclotron frequency omega E is much less than omega, so neglecting 1 in the denominator. Omega E is much greater than this omega. So omega E square upon omega square is much larger quantity. So we neglect this 1 in the denominator, and then we have Vex as equal to IEEx upon m omega. This one is neglected, and we have omega E square upon omega square into 1 minus k square gamma E k Te upon m omega square. We can write this as IEEx upon m omega. This bracket term is now written in this way. In the denominator term becomes now numerator, and it becomes omega square into 1 minus k square gamma E k Te upon m omega square upon omega E square. Now we write it as IE upon m omega square upon omega E square 1 minus k square gamma E k Te upon m omega square Ex. Write Ex in the last. Again, in next step we neglect the 1, because the second quantity inside the bracket will be much greater than 1. And now this value of Vex is obtained as I k square gamma E Here we put the value of omega E at EB upon small m and solve it to get Vex equal to I k square gamma E k t E upon omega E b square Ex. Now substituting the values of Vix and Vex from equations 8 and 14 into equation 12, then we get this relation Ex into omega square minus c square k square equal to minus 4 pi I omega n0 E into these two terms. First term for ion and second term for electrons. Now we simplify this. Ex is on both sides, so we cancel Ex, and now we have omega square minus c square k square equal to this expression. Here we eliminate Ex from both the sides. In next step, we write the first term inside the bracket as IE into 1 minus k square gamma I k t I upon m omega square. It is LCM in denominator. So we take LCM in denominator. So it comes up, and in denominator we have m omega into 1 minus we multiply the first term by 1 minus k square gamma I k t I upon m omega square in numerator and denominator and get this expression. And the second term is same. In next step we write it as minus 4 pi n0 E square. So we multiply this term outside the bracket to both the sides. And 1 minus k square gamma I k t I upon m omega square is much less than omega I square upon omega square. So we neglect this term 1 minus k square gamma I k t I upon m omega square, because omega I is much greater than omega. Ion cyclotron frequency is much larger than this frequency omega. So we neglect 1 minus k square gamma k ti upon m omega square. In this term, in the denominator, in the first term inside the bracket, we neglect these first two terms in comparison to the last term. Then this equation reduces to this. Now we simplify again this and get this expression. Take omega square to numerator. Second term is the same. In the next step, we write the value of omega I. Omega I is EB upon capital M, ion cyclotron frequency. Put this value of omega I. Second term remains the same. Now first term becomes this, and in this second term we multiply by capital M and divide by capital M. And since alpha velocity VA is CB upon under root 4 pi rho, it is CB upon under root 4 pi N0M. Rho is density of ions, so it is N0 capital M. Since alpha velocity VA is CB upon under root 4 pi N0M, so 4 pi N0 M upon B square is equal to C square upon VA square. We write from this expression the value of C square upon VA square as 4 pi N0 M upon B square. Since 4 pi N0 M upon B square is C square upon VA square, that's why we multiply and divide by capital M in this second term in previous equation, so that 4 pi N0 M upon B square now becomes C square upon VA square. So in the first and second term of right hand side, we put 4 pi N0 M upon B square as C square upon VA square, and then omega square minus C square K square becomes this, minus C square upon VA square omega square into 1 minus K square gamma I K T I upon M omega square plus C square K square gamma E K T E upon VA square M. Simplify this equation, solving this bracket, and we get now these three terms in right hand side. Take the term of omega square to left hand side. There is one term of omega square in left hand side and one term of omega square in right hand side. Put these two terms of omega square together to left hand side and take this C square K square to right hand side. We have omega square into 1 plus C square upon VA square equal to C square K square plus C square upon VA square K square gamma I K T I upon M plus C square K square gamma E K T E upon VA square M. Now simplify this right hand side, take C square K square common, we have c square k square into 1 plus 1 upon Va square gamma I kTi upon m plus gamma E kTe upon Va square m. In right hand side, inside the bracket, in last two terms take 1 upon Va square common. Then with 1 upon Va square we have gamma I kTi plus gamma E kTe upon m, and this quantity inside the bracket we write as Vs square. Vs is under root gamma I kTi plus gamma E kTe upon m. It is the velocity of ion acoustic wave, that is sound wave. So if we write it as Vs, then omega square into 1 plus c square upon Va square becomes c square k square into 1 plus Vs square upon Va square, or omega square upon k square becomes c square into 1 plus Vs square upon Va square upon 1 plus c square upon Va square. Take LCM. This omega square upon k square becomes c square into Va square plus Vs square upon Va square plus c square. In this way, this omega square upon k square we write as Vm square. Now Vm becomes c under root Va square plus Vs square upon Va square plus c square. It is the velocity of magnetosonic wave. We write it as Vm, velocity of magnetosonic wave. In the absence of magnetic field, Va is 0, and then Vm becomes Vs, that is velocity of ion.